We're now going to look at trig equations, and this will play a big role in the class because in calculus you often take the derivative, set it equal to 0, and then you got to find the places where the derivative is equal to 0, and that involves solving an equation. And if your original function is a trig function, as a lot of them will be, you will have to solve trig equations. And so I'm going to try to quickly go through several different things that you need to know in order to be successful at this. First, we start with these basic trig equations, and this is really important because everything's going to boil down to a basic trig equation, or multiple basic trig equations. Okay, so it kind of, every problem reduces down to one of these, or not one of these four, but to a basic trig equation. Okay, and here's the point. So you want to know what x values gives a sign of negative 1/2. Okay, well, let's look at the unit circle. And the sign is the y coordinate, right? So when the y is 1/2, that's like down here. Okay, negative 1/2. But the thing is, there's actually two places that give you negative 1/2, two angles. So between 0 and 2 pi, there's two angles that are going to give you a sign, a y-coordinate of negative 1/2. And so these are this is a special angle, right? So this one is 7 pi over 6, and this one is 11 pi over 6. So this is why knowing the special angles in the unit circle is important here. So both of these will satisfy that equation. Okay, but you're still not quite done yet, because if I go all the way around and then stop again, that would be another solution, and then around again would be a solution, and around again. There's actually an infinite number of solutions. And so what I do is I take, these are kind of the main ones, the basic two. The first two are the ones that are between 0 and 2 pi, right? And so I'm going to take those, and then I'm going to add all the multiples of 2 pi. And this is like all the rotations, okay? And for this one, I'll do the same thing. Plus k times 2 pi. So it would have all the multiples, okay, of 2 pi. And so this would be all the solutions, an infinite number, okay? But you got to have both of these angles. So one would be all the rotations that land here. The other one would be all the rotations that land there. Okay? So now this is a basic trig equation. So a basic trig equation, let me define it. I didn't define it before, but it's basic. It is when you have a single trig function, just like this, equal to a number on the other side. When you can reduce it to that. And in this case I can, because I can move the square root of 3 to the other side, and then I can divide both sides by 2, and then what I get is cosine x is equal to square root of 3 over 2. And that is a basic trig equation, right? And it's just also a special angle. Now it's cosine, so this is when the cosine, or the x-coordinate, is equal to negative square root of 3 over 2, which would be like over here somewhere, square root of 3 over 2. Okay? And there's going to be two values that give you that. This one up here, okay? And that one is the pi over 3, okay? And then the other one that'll give you a positive square root of 3 over 2 is the one down here, okay? And so, and that's going to be 5 pi over 3. Okay, there's 6 of them, back up one, that's 5 pi over 3. And so these are the two solutions between 0 and 2 pi that'll give me square root of 3 over 2. Okay, so if you have a sine, the two solutions are across from each other horizontally. And if you have a cosine, the two solutions are across from each other vertically, okay, like this. And so now we got to write the solutions like this to get all of them. So we have pi over 3 plus k times 2 pi, and then we have x is equal to 5 pi over 3 plus k times 2 pi. and these would be the solutions for this equation. Those would be all of the solutions. Okay? Now, for tangent of x here, you want the ordered pair that's going to give you this. I recognize this as one of the special points on the unit circle, and it takes some time to get used to this, but I know this is one of the ones that are going to relate to a pi over 6 angle, okay? And this will also have a negative, this will also have a negative, it has to be negative, right? The value has to be negative. So if I use this one, which is where I have square root of 3 over 2, negative 1/2, I can show you that this is going to be, and this point here is actually 11 pi over 6. So the tangent of 11 pi over 6 is equal to the y, negative 1/2, over the x, square root of 3 over 2. And then I can just double check here. So negative 1/2 to square root of 3. These cancel out, and I get negative 1. I'm sorry, yeah, negative 1 over square root of 3. And this is equal to, I multiply the top and bottom by the square root of 3, right? To rationalize it. And there I see I get this answer. So that's one of the solutions. But the thing here about tangent is you don't need two solutions, because the other one that would give you this is actually going to be, so it'd be like this. Oops, sorry. It's the one that's directly across from it. It'd be like over here, and it would be where you would have a negative 1/2 and, I'm sorry, a negative square root of 3 over 2, and then a positive 1/2. So it would be the same ordered pair, but the other coordinate is negative. But notice this is just pi. Okay? So what I can do is I can just find the one solution, kind of closest to 0 here, 11 pi over 6 or whatever. So 11 pi over 6. And then I can add all the multiples of pi, because the period is pi. So within, basically, here, within one cycle, from 0 to 2 pi, within one period, there's two solutions. And so you got to list both of them and all their rotations. But within one period of tangent, there's only one solution. And so then you can just take the one solution and then add the multiples. Not of 2 pi, but of pi. Right? And then you get all of the solutions. And you're done there. Okay, so the cosecant of x is equal to 2. So how would you solve something like this? Well, what I'm going to do is, so I have cosecant x equal 2, and then I'm going to change the cosecant to 1 over sine x is equal to 2. And then I can move the sine up and the 2 down. And then when I do that, I get sine x is equal to 1/2. Okay? And so basically, that's a lot like this equation, right? Except now it's positive 1/2, so it'd be up here, 1/2. And so you would have the two solutions here and here, and it'll be just like these here. So this is like square root of 3 over 2, 1/2, and this is negative square root of 3 over 2, 1/2. And the y coordinates is what you're interested in. I guess I didn't have to write those ordered pairs out. The reason I wrote the ordered pair out for this one is because I had to put in the x and the y in here to see if it was the right solution, okay? But here I don't have to put them in because I just know I'm just interested in the y coordinate, which happens here and here, okay? And so this is just the pi over 6, and this is the 5 pi over 6, right? And so my two solutions would be x is equal to pi over 6 plus k times 2 pi, and x is equal to 5 pi over 6 plus k times 2 pi. Okay? And those would be your solutions. Now these are all equations. You know what? I am sorry. I just looked at the camera and I just noticed that they were off the camera, and so I apologize about that. So there you go. Those are the solutions. So these will always be converted into a sine or a cosine. Okay, the cotangent can always be converted into tangent, or you could do it as look for the ordered pair that solves a cotangent. Okay, but those are all special angles. So oftentimes in real world examples, you don't get a special angle. Okay, you would get maybe an equation that looks like this, okay, where this isn't one of the special angles. And so first of all, you got to make sure that this number here is between -1 and 1, because if it's not, then you don't have a solution for it. Okay, so this has to be a number between -1 and 1, and it is. And so the way to do this is you're going to draw your diagram. You're going to rely on this diagram. And this is something that I don't have a lot of time to go into, but when you use a calculator to find the angle that gives you this, it's going to give you an angle between 0 and 2 pi. I'm sorry, 0 and pi, sorry. It's going to give me an angle between 0 and pi. Okay, and so what I'm going to do then is I'm going to take cosine inverse of -0.85, because I don't know the angle off the top of my head. Okay, I don't know that angle off the top of my head, and so the way you do this on your calculator is you hit second cosine, and then you put -0.85, okay? And it's always a little weird because it's a real number. It's not the number of degrees. This is a radian, but it's 2.586. So maybe I'll round to 2 decimal places. So approximately, or I can round to 3 decimal places. I'll round to 2.59. Okay, and so basically what that is here, it's the angle between 0 and pi that gives me -0.85. So this is a cosine, and a cosine is the x-coordinate, right? So this is like -0.85 right here. And it gave me this angle. So it means that this arc length, or the number of radians here, is 2.95, right? Because like if you go all the way around here, this is pi, which is 3.14. So this is 2.95. So that's one of the solutions. But then the other solution goes down here. And so the question is, what is this one here? So the calculator will give me the one from 0 to pi. I have to find this one. Well, the way that I do it is you're going to take, this is 2 pi, right, all the way around. And then I need to back up this distance to get to here. Well, what is this distance? Well, that distance is the angle 2.59, because the curve is symmetrical, right? So my other solution here is going to be 2 pi minus 2.59. Okay? So let's find out what that is. 2 pi minus 2.59. And I get approximately 3.69. And so this is my other angle. So 2.59, 3.69. Okay? And that's how you have to do it. This takes some practice. It takes a knack getting used to it. Okay? But that's how you would do that. And so my two solution sets then would be 2.59 plus k times 2 pi. And then x is equal to 3.69. Plus k times 2 pi. And so I get the solution for that. Okay? So Maybe what I should do is I should do a sine one as well, okay? And I'll do that in a moment. I didn't think about that, but I'll do that in a moment, and I'll show you why I'm going to do that. But let me show you that the tangents are easy. The solution is basically tangent inverse of whatever it is plus k times pi. You don't have to worry about the circle or finding another solution or anything. You just do that. So in this case, tangent inverse of 13 is 1.49 if I round to 2 decimal places. 1.49, and then it'll be all the multiples of pi, not 2 pi but pi. So tangent is no big deal. Tangent is pretty easy. Okay, but let's try one of sine. So let's say I have sine x is, we'll say is equal to negative 0.2, we'll say negative 0.2. Okay, well, the way that sine works when you do an inverse sine, okay, so if I do sine, this isn't a special point on the unit circle, so I got to do sine inverse of negative 0.2. Okay, and the way that the sine works here is it's going to give you an angle between negative pi over 2 to pi over 2. Okay, so it's going to give you an angle from here to here, and that's different than cosine. It gives you an angle from 0 to pi, and this all has to do with functions, and that the piece that you have to invert has to be 1-to-1, all this stuff from pre-calc. I'm not going to go into it, but the cosine, inverse cosine, will give you the angle from 0 to pi, and then you have to find the other one. The inverse sine will give you the angle from negative pi over 2 to pi over 2, and then you have to find the other one. So basically this is the y coordinate, it's negative 0.2, right? Negative 0.2 here, and it's going to give me this angle right here, right? Okay, and that'll be pretty small, okay? So I get the sine inverse of negative 0.2, and then look at this, I actually get negative 0.201, and maybe I'll round this to 3 decimal places, just so that these are not the same, exactly the same, but they're very close to each other. So the sign, when you're close to 0, the sign's going to be close to the angle, and the angle and the sine value are going to be close to one another. And the reason is that this distance as you go down is pretty close to this distance here on the y-axis. So this arc and this are pretty similar. As you go more, this and this, the difference will be bigger, right? And of course by the time you get over here it'll be a lot bigger. But at the beginning here, they're going to be close to one another. That can be kind of confusing. Okay, now the other solution is going to be the one over here, because remember sine goes across, right? So how am I going to get that? Well, this is like pi, and then I'm going to go this little bit more, right? So I'm going to take pi, and I'm going to add 0.201. I'm not going to subtract and get this angle. I'm going to add this angle. So this angle and this angle are the same. So I'm going to take pi, and I'm going to add 0.201. And when I do that, I get 3.343. It'll round to that if I round to 3 decimal places. Okay, so these are 2 solutions. Now you might want the 2 solutions. You don't have to. You could use these 2. But me personally, I like to get the 2 solutions that are between 0 and 2 pi before I do this. So if I want to do that, all I have to do here is take 6 pi minus 0.201. So 6 pi is all the way around, and then I go back that little bit, and that's going to give me the coterminal angle here. That's going to be between 0 and 2 pi. And I get like 6.082. So I'm going to use those two angles. You don't have to. You'll get the same solution set, but I think it's nicer to do that. And so I have 3.343 plus k times 2 pi, and x is equal to 6.082 plus k times 2 pi. Okay? And there you get those. So those are trig equations that are not special angles. You have to use your calculator in the inverse trig function to do it. Okay, well this is called a multiple angle equation, and it's not a big deal. This is very, very easy. Basically what you're going to do is you are going to find the solution. Don't worry about the 3. So what makes this a multiple angle is the 3 inside the sign being multiplied by the x. So I'm going to just find what angle 3x has to equal to. Okay? And so basically I'm going to just solve this as if it were a regular one. Okay? And negative square root of 2 over 2 is like right here. This is sine, so it's on this axis. Negative square root of 2 over 2, right? So this is the 2 points. So this one would be 5 pi over 4, and this one would be 7 pi over 4. Those are going to be the two. That's a special angle. It's a pi over 4 angle, right? The 45-degree angle. And those are the two solutions. So now, this would solve just the equation sine of x is equal to that. Okay, so 3x has to equal this. So basically, you're just setting it up like before, but now instead of x equals 5 pi over 4 plus k times 2 pi, 3x has to equal that. And then you have one extra step. You just divide both sides by 3, and this becomes x is equal to 5 pi over 12 plus k times 2 pi over 3. So I'm dividing this by 3 and that by 3. And then similarly, 3x has to equal 7 pi over 4 plus k times 2 pi. And so then I divide both sides by 3. That cancels out, and then I get x is equal to 7 pi over 12 plus k times 2 pi over 3. So basically what you're doing here is the exact same thing as before, but you have the extra step of solving for x at the end. You're setting whatever's inside here, you're setting it equal to the solution set, and then you're solving that for x. Okay, and that's just, they refer to that as a multiple angle. Okay, trig equation. And so not a huge deal there. So, boy, this marker's running out. I think all my markers are kind of getting low. But let's see if this one's a little better now. Okay, so now what about more advanced equations? Something like this. Well, here, depending on the equation, it can be really, really complicated, or not too terribly difficult, or it might be that you can't even solve it algebraically. It just depends. And it really takes time working with trigonometric functions to get a feel for all this. But the first thing that you can learn is to bring everything to one side and factor. Factoring is the way that you solve equations like this. And let me show you why. So what I'm going to do is I'm going to bring the square root of 3 cosine x to the other side. So I get 2 cosine x sine x minus square root of 3 cosine x. And that's equal to 0. Now what I can do then is I can factor a cosine x out. So I get cosine x times 2 sine x minus square root of 3. This is equal to 0. So here's the strategy. You move everything to one side and you factor. And if this is equal to 0, it's important. You have to have a 0 here. Then it's like when you're solving quadratic equations, right? Either cosine x has to equal 0, or 2 sine x minus square root of 3 has to equal 0, right? But these would have to, if either of these are equal to 0, then the product will be equal to 0. And so what you've done is you've taken this more complicated equation and you have reduced it into two basic trig equations. And all you need to do is solve each of those basic trig equations. So cosine x equals 0. Well, let's see. When is the cosine x equal to 0? Well, it's equal to 0 over here when... no, it's not. It's equal to 0 up here, right? The x-coordinate is 0. So either at pi over 2 or down here at 3 pi over 2, right? So you would get the solutions x is equal to pi over 2 plus k times 2 pi, or x is equal to 3 pi over 2 plus k times 2 pi. Okay, so then you have this equation. Notice I can move those to the other side, and I get sine x is equal to square root of 3 over 2. And that's also a special point on the unit circle. So that's nice. This is the sine now. Let's see here. So the sine square root of 3 over 2 would be up here. Sorry, I was confusing myself for a second there. Okay, so basically your two solutions are over here, which is pi over 3, and then your other one is over here, which is 2 pi over 3. And so what you get here is x is equal to pi over 3 plus k times 2 pi, and x is equal to 2 pi over 3 plus k times 2 pi. And these are the solutions to this equation. Okay? Let me also make a point here that this solution set can be reduced into the following. X is equal to pi over 2 plus k times pi. And why is this? Is because this is a special place where if I add pi, I get to the next one. Add pi, I get to the next one. Add pi, I get to the next one. And then you'll get all of them in this one simple thing. So both of these can collapse down into there. But you don't have to do it like that. You can write it out just like this. Okay? And so now, let me do one more. And this is very similar where you're factoring here, except I'm going to use a trig identity to help me. So I have sine of 2x is equal to cosine of x. But sine of 2x, that's like the double angle identity, if you remember. And that's actually equal to 2 sine x times cosine x is equal to cosine x. And that's very similar to this. I can move the cosine x to the other side, set it equal to 0, and now I can pull out, in this case, cosine x, and then I get 2 sine x minus 1 is equal to 0. And so I get these two equations. Cosine x is equal to 0, and sine x is equal to 1/2, a positive 1/2. And this one is the same as that, right? So I could write that as pi over 2 plus k pi if I want to keep it nice and simple. And this one is very similar to here. It's positive 1/2. Okay, so it's the x is equal to pi over 6 plus k times 2 pi, and x is equal to 5 5 pi over 6 plus k times 2 pi. It's basically this point here and this point over there, 5 pi over 6. And that would be the solution for this. The idea here is the trig identity. You were able to split it into this, and then it easily factored apart. So you can, if you can use an identity that can help you then factor things apart, if you can do that, then that's great as well. Let me make one other point here, and that is, one thing you don't want to do is, you might think, oh, I'm going to divide both sides by cosine x, and then I can get, it's like you're getting rid of that. But if you do that, then you would get 2 sine x is equal to 1, and then you would bring or you would get 2 sine x is equal to square root of 3, and you divide both sides by 2. You would get this equation, but you would miss out on all of these solutions here. Okay, so you never cancel out a trig function. Okay, you always bring it to the other side and factor it out. Okay, and so that's important. Now there's a lot of other ways of solving these more advanced equations, either using identities. Sometimes if it's you call it an equation of the quadratic type, you can use the quadratic formula to solve, and then you would set equal the trig functions to the solutions of the quadratic formula. Since there isn't any of those on the homework, I'm not going to do it now, but we might see that later on, and I'll teach it at that point. But this is how you solve trig equations, and of course there's a lot of other types of equations that you can solve. Okay, so I hope that is a good start for you, and it certainly is all that you need, I think, to do the ones that are on the homework.